Hello students, hope you are all having a good time. In today's class we shall discuss about resistance of a conducting wire and what are the factors on which the resistance depends upon. Now let us see, resistance is nothing but whenever electrons are flowing, it faces opposition because of the impurities as well as the lattice ions, that is the nucleus. So whenever the electrons are moving, they face opposition. This opposition to the motion of electron is called resistance. Resistance depends upon number of factors like temperature, nature of the material, length of the conductor, area of cross section. Now let us take a circuit like this. Keep a bulb here and note down the resistance of this bulb without battery. It will give you some reading. Now connect it to a battery. What happens? The bulb starts glowing. You will find that the resistance value increases, resistance of the bulb increases. Why does it increase? As the electrons are moving continuously, the temperature of the wire increases. Because of number of collisions or the collisions between the electrons and the lattice ions increases. So as the temperature increases, what happens to resistance is resistance increases. So that is about temperature. Nature of material. Next what you do is to take a circuit like this. This is the wire, this is the battery, ammeter and a switch. Keep different types of wires across this area, across the space that you have left, space PQ. These wires should be of same length and same cross section area. Once take copper wire, another time take iron wire, and the third time you take aluminium wire. You will find that each time the current value is different. This is because the arrangement of the lattice ions and the number of impurities that is present for each material is different. So because of this the current is different. So the resistance depends upon this shows that resistance depends upon the nature of the material. Next, length of the conductor. Next time what you do is take the same circuit and take different lengths of copper wire. Let us say first you are taking 10 centimeters, next take 20 centimeters, next take 30 centimeters and attach it between these two wires. Next time I am taking 20 centimeters, third time I am taking, let us say 30 centimeters and I am placing it between the gap like this. So what you observe is, as the length of the wire increases, the resistance also increases because the number of lattice ions and the impurities increases as the length increases. So because of which the resistance decreases. So resistance is inversely proportional to the length of the wire. Now is directly proportional to the length of the wire. It is directly proportional, as the length increases, resistance also increases. Now next you have area of cross section. Take wires of same material but of different area of cross section. Let us say first time I am taking thin copper wire, next time I am taking thicker copper wire. So as you increase the thickness, what happens is electrons have more space to move around. Although if they face the lattice ions, they have more space to escape and move because of the thickness of the wire. So as the thickness increases, the resistance of the wire decreases. That is, resistance is inversely proportional to area of cross section. It is directly proportional to length of the conductor. If you combine these two, you get R is directly proportional to L and inversely proportional to A. Now remove this proportionality symbol, you keep a constant. This constant is called resistivity. Constant rho is called resistivity. Now resistivity depends upon material of the wire as well as temperature, whereas resistance depends upon material, temperature, length of the wire, area of cross section, number of factors. Okay, resistance depends upon number of factors like this. Resistivity is nothing but the resistance offered per unit length of the conductor, that is, let us say 1 meter. What is the resistance offered? If you take 1 meter of wire and of certain thickness, what is the resistance that is offered? That is resistivity. Unit of resistivity is ohm meter. Resistance is measured using, the unit of resistance is ohms. So that's about today's class, children. We shall continue in the next class.